This is my demo on how glucose transport works. On the left, we have the gut lumen. It is connected to the epithelial cell through a SGLT1 cotransporter. This cotransporter assists in transporting sodium and glucose into the epithelial cell. On the right, we have the extracellular fluid. We can see that it's connected through the epithelial cell through a sodium-potassium pump. Sodium is in purple, water is blue, glucose is green, and potassium is orange. We can see in the gut lumen that there's a high concentration of sodium already. It wants to go towards the low concentration in the epithelial cell. The gut lumen can be considered as hypertonic, mainly due to a high concentration, where there is a low concentration in the epithelial cell. The epithelial cell can be considered as hypotonic. The sodium is going to be transported into the epithelial cell with the glucose through facilitated transport. Now that there's a high amount of solutes inside the epithelial cell, water will naturally diffuse towards it, following the glucose. For the epithelial cell to continue receiving glucose, it must be able to reduce the amount of the concentration of sodium inside the cell. By doing this, it will be transported through the sodium-potassium pump. Because there is a higher concentration in the extracellular fluid of sodium, this potassium pump must be driven by active transport, where energy is needed. Once ATP is available, the sodium-potassium pump will transport 3 sodium ions into the extracellular fluid. And in return, 2 potassium ions will be transported back into the epithelial cell. This concludes on how glucose transport works.